Hello, welcome, namaskar, marhaba guys, sat shri akal, hola, bonjour, hi Shiva, hi Yadla, hi Chali boys, welcome aboard to the Zero to Superhero series, where this is a one-shot revision series for all the JEE as well as the NEET aspirants preparing for the 2022 exam. And today's session is all about, like you can see, electromagnetic induction and also AC current, very much related chapters, important chapters from the competitive exam perspective. Lots of questions today, and I want you to practice a lot of good things. Apart from that, I will also give you a quick recollection of all the important concepts via a mind map, and also I'm going to give you my handwritten notes. So, well, those of you who do not know me, my name is Shreyas, guys. I'm the physics master teacher at Vedantu, and I'm going live out here on VE Enlite. VE Enlite is an English medium channel for all the students who want to prepare for exams like JEE, NEET, KVPY, BITSAT, you name it. And also we did a marathon session for board examination as well last week. So stay tuned on the channel by hitting the subscribe button. And also remember, once you have subscribed, you need to necessarily hit the like button so that we guys get encouraged to conduct more such sessions just for you. So let's begin with the class, and remember, there is also a link in the description box below for joining the Telegram group. Make sure you are a part of it, or else you will be missing out the PDF. Alright, so that's where the description box is. You can see there is also a VE quiz link right over here. So this VE quiz link is basically an assignment, and every session you will get an kind of an assignment which you can solve and you can practice in a timed manner. So make sure you click on this link. The VE quiz will open up. All right, so that's what it is. You can see the crash course links are also here, and you can also see the Telegram group link is also right over here. Hello Rihan, hi PL, hi Meera. Nice to see some of the new warriors out here. Good evening Balamurgan. Hello Shruti, Jamesburg, Shiva what? I'm not sure where. Shiva Vaithunathan, I guess. Good evening sir, just dropped by once again to thank you for helping me for my perfect physics exam. I'm so thankful to you because all your efforts made my physics exam go like piece of cake. I'm so happy for you, Syed. Let's also work for NEET and JEE now. I'm pretty sure after your bio or maths exam, you will be all in into the competitive mode. Okay, so thank you so much, Modern Man. Thank you so much, guys. Hi Shekhar, hi Fahi, hi Narbavi, hello Shiva, hello Nandana. Good evening, everyone. Now, today's class, I'm going to start with mind map. See, mind map is very important to revise in the evening, in the night before sleeping. Trust me, not only will you recollect all the concepts, but you'll also get very good sleep. Does it happen to you that when you are trying to think about what you did during the day or what is there in a particular chapter, let's say for example, I tell you, recollect whatever is there in EMI. Eddy current is there, Motional EMF is there, Lenz law is there, Flux is there, inductance is there. Achha, what is there in inductance? LCR circuits are there, self-inductance is there, mutual inductance is there, Faraday's law. Okay, I know the value and I know how flux can change. So when you start thinking, one of these two things happen. Either you become very sleepy or you get very tense and you wake up like, oh my god, I don't know this, I need to study this. So good if either of them happens. And thank you Fahi Edits, you guys saw my dual nature and you started learning physics. I'm so glad about it, so glad. PL, magnetism is already there in the playlist. Just check the Pathfinder. It's anyways, you know, a theoretical chapter, more of tables and your facts based questions and all those things and standard formulas based on substitution. So just check out my Pathfinder 12th playlist, magnetic properties, materials and earth magnetism. You can do it from there. Vanakkam normal human. Wow, not so normal. Rihan, you will go to any IIT, whatever you want if you dream about it. Okay, just have the dream. The dream is important. We will make that happen. Okay, keep working hard. The dream should be there, but don't just keep dreaming. You have to put your effort into actions. Only those actions can lead you to IIT. Let's do this. Okay, so let's begin. And guys, let me tell you, tomorrow at 5 o'clock I'm going to have a casual talk session with all of you. Okay, so be there. It's open for all. It's not like only for 12th, only for JEE, only for NEET, nothing. No bias, no, no mention of which branch or anything. You can come as per your need, and it's also open for 10th to 11th, 11th to 12th. If you have your juniors, your younger classmates, buddies, or anybody whom you know who will be benefited, just ask them to come. We'll have a casual talk. That's it. I'll try to answer as many doubts as possible, but sometimes I can also miss few things. And 7 o'clock, a motivational class based on the learnings from the Chennai Super Kings, of course, the 5 things that you can learn. Now, see, let's try to recollect this. Flux, then we'll go to Lenz, then we'll go to Motional EMF, we'll also go to Eddy, and then we'll go to Inductance. So this is the cycle, and I'm going to quickly revise through all the concepts because I have a lot of questions that I want to revise, because theory wise it is not too much, and then we also have AC which we need to revise. So talking about flux is basically the flow of something, and the magnetic flux tells you the flow of magnetic field lines. So if you have an area A, magnetic field B, the flux through it is given by BA cos theta, unit is Weber. It is just like electric flux. If you recollect, it was electric field into area into cos theta. Here it is magnetic field dot area vector. As simple as that. Now Faraday saw that if you take a coil and you take a magnet, that magnet will create field lines. Some of the field lines will pass through the coil, and as you move the magnet, the flux through it changes. Or you have another coil which carries some current, and you place some another coil which can measure the voltage or the current, and when you turn on the switch, turn off the switch, or you change the voltage, the field created by one coil passes through the other coil. When the current changes or the voltage changes, the field lines change. When the field lines change, you saw, or the Faraday saw basically, that the flux change caused some electricity. So he came to that idea that whenever there is a change in the flux through the coil, there is an electricity which is created inside that coil, and that electricity depends completely on how quickly that flux changes. So the rate of change of the flux, magnetic flux through the coil, is given by, or rather it gives you the EMF induced in the coil. Induced as in it has been created inside it without touching anything. It's just wireless transfer. I have induced knowledge into you. I have not touched you. Wirelessly I have induced knowledge into your heads. That's what it is. Okay. Shibala, class 11 sessions will not start. We will have problem solving sessions. 11th standard classes are already present on YouTube on this channel. The entire detailed playlist is there. Please start watching it. Don't waste your time. Don't think live classes are only good. No, start watching those classes which are there. I'll conduct problem solving series as well. Don't worry about it. Marhaba, Yogesh. Now d phi by dt. Oh, why have I put a modular sign? Am I scared of something that it can become negative? Yep, I think I am. Hi, Yuvashri. Because in Lenz's law there is a minus sign. I'll come to it in a bit. So the magnitude is d phi by dt. You can also write current. So if EMF is created, obviously current is created. Current is EMF by resistance, and current is dq by dt, and EMF is d phi by dt. You can see that dt will cancel, and sometimes this relationship is very useful. dq is flux change by resistance. There are so many questions based on that. Okay, so this is the slide for Faraday's law and magnetic flux, which will help you revise all the concepts. Then we talk about Lenz's law. Lenz's law is all about the direction, completely based on the energy conservation, and that is the one which gives you that minus sign in that equation. See, whenever the flux will try to increase, right, Lenz's law will say that a current which is created or induced will try to oppose that change. So if the flux tries to increase, the induced current will try to make it weaker, and if the flux tries to decrease, it will make it stronger. Example would be, imagine if you have a coil like this. Okay, and oh, I don't know the directions right now. Hold on. So let's say I have a coil like this. This is the axis. There is a magnet over here. This is the north pole. This is the south pole. Let's say I take this magnet right over here. I'm trying to take the magnet towards the coil. Think about it. Will the current induced be clockwise or anti-clockwise? I want your answer in the chat box. Gautam, at least 50 bacha. 50 to 100. Anywhere. Depends on the difficulty and all that. How to visualize induced current? That's what I'm going to teach you, Gautam. Observe this now. So, see, Faraday's law is a little bit simple only, magnitude wise, because it's just derivative or find the change upon the time. Many students face problem in the direction. Okay, Shiva is saying clockwise. Fahi, will you need any previous knowledge? Well, yes, little bit knowledge of magnetic fields, little bit knowledge of flux, little bit knowledge of current, electricity and all of that. Yep. So the ALI course starting on 6th June covers both 11th and 12th syllabus, depends. Gauri Shankar, if you join the 11th batch, it will cover both. If you join the 12th batch, then it will cover 12th syllabus, but 11th revision. So if you join the 12th batch, still both things are covered, but only 11th revision will be done. Problems, practice, theory revision and all that. But if you join the 11th batch, you will get the detailed classes of 11th as well. Okay, anti-clockwise? Well, whenever such questions come, always try to solve it this way. That Lenz's law says that whatever happens, it will oppose. So this magnet is trying to go close, this coil will repel it. This coil will try to repel it. It does not like coming close. So it will develop a polarity like this. This will be north, this will be south. This will be north, this will be south. So that north will repel each other. Now if the north is here, think about it. How will you create north pole this side? That means you have to create a magnetic moment this way. So hold your thumb of right hand this way. Fingers will curl like this. See how my fingers are curling? So hence the current will be like that. That's how you have to figure out. As simple as that. Got it? Understood? So it is definitely anti-clockwise. So this is what Lenz's law is all about, based on energy conservation, that whenever anything tries to happen, it will oppose it. If the magnet would try to go away, then it will try to pull it back. It will attract by creating opposite polarities. If it tries to come closer, it will create similar polarities. As simple as that. Okay. Now, motional EMF. Let's talk about the second aspect of, your how electricity can be induced. One aspect was by your Faraday's law. Now over here, if you see, Faraday's law says EMF induced is minus d phi by dt. So flux is B into A into cos theta. You will realize this very quickly, that either B changes or A changes or theta changes. Any one of these three things change, the inside part will change. Hence, there will be some change in the flux that will create EMF. Example, B changes, meaning there is a coil. I bring a magnet close by. So when I bring a magnet close by, the magnetic field lines passing through it will change. So B changes, that will create EMF. Number one. Number two, let's say theta. There is a coil, there is a magnet. Field is same, coil area is same. I rotate the coil. If I rotate the coil, the area vector will tilt, theta will change, this derivative will have some value, EMF will be created. In fact, that's the principle of a generator. A coil keeps rotating, it creates EMF. A changes. Imagine I have a coil, I have a magnet. I extend the coil, I rearrange the coil, I try to pull it, push it, I change its shape, size, something like that. So area changes, again EMF will be created. So either one of these three things or more than one things changed, you will see EMF will be created. Now there is one more way of creating EMF, and that's just moving a conductor through a magnetic field. That is why it is called motional EMF. Just because of the motion of the conductor, you will see EMF is created. And that conductor's length is L, magnetic field is B, velocity is V. The EMF created is not BLV. A lot of people just bahite it as BLV, that's wrong. It is L dot V cross B. L dot V cross B, and the EMF, the battery that you can think of, an equivalent battery which can substitute this conductor, has a direction which is in the direction of velocity cross magnetic field. Let me give you an example and let's see if you guys can figure it. Okay, let me just draw an example and let's see if you guys can make it through. Imagine guys, this is one conductor. Okay, this is one conductor. Okay, and let's say the conductor is moving this way, this is the length, and the magnetic field is this way. Magnetic field is this way. You guys quickly tell me in the chat box, where will the EMF be created? Option A, it will be created upwards. Option B, it will be created downwards. Option C, there will be no EMF created. Come on, put it up in the chat box. Can I opt being a dropper, Gauri Prakash? Yes, definitely. But I don't think you should be thinking about drop. Depends on what you're trying to write. Is it 2022 or is it 2023? Length is like this, velocity is like this, magnetic field is like this. Hello, Enlight's product. Upwards or C? Okay. Looks like many of you are correct about this. Very good. Velocity and magnetic field, V cross B will be 0. Velocity is parallel to magnetic field. Cross product is basically sine. So sine 0 is 0. That's it. Anything into 0 is 0. So EMF will be 0. There will not be any EMF in this. No EMF as such. Very good. Let's take another example. Let's say we have a rod and that rod is like this. And let's say the rod is moving this way. This is the velocity. This is the length of the rod. And the magnetic field, as usual, is, let's say, like this. This is the magnetic field. Now tell me, what is the EMF induced across the ends of the rod? Across this end and across this end. So what's the net EMF induced across the rod? Come on. Option A is this way. Option B is this way. Option C is no EMF induced. Jamesburg, nobody is trying to copy your answer, bacha. People are writing it independently. Don't worry about others. Just focus on what you are writing and what I am teaching. That's all. Don't know, Shiva? Okay. The dot product in the formula also, that means if you expand it, we'll get both sine and cos. Yes, I don't know. This dot is basically your cos. This is cos. This is sine. And do you know what is this whole thing called as? If you are a math student, you would know it. If you have studied vectors in maths, come on. Dot and cross. Three things multiplied, triple product. It's called as a triple product, but the final answer will be a scalar because you are doing a dot after the cross and then dot. So when you take dot product, always the answer is scalar. Hence scalar triple product. Very good. Okay. So guys, what will happen in this case? Okay, let's do this. V is here. Velocity is that side. Magnetic field is inside. Come on, hold your right hand 4 fingers in that side, velocity's direction, and curl it towards magnetic field. V cross B. See, where is your thumb going? It's going there. Thumb is going there, right? So this is the direction of V cross B. Good enough? Now where is length? Length is this way. Either that way or this way, doesn't really matter. The funny part is, it's perpendicular. Length is perpendicular. So when you do V cross B dot L, the dot has cos 90, 0. That's it. The answer will be no EMF which will be created. Got it, guys? So that's why you should remember this formula, L dot V cross B. Very useful for solving problems. The EMF is always created in the direction of V cross B. Got it, my warriors? Understood? So V cross B was up and V cross B dot L 0 because they are perpendicular. Okay. Now, this is one formula. So usually EMF is generated in this case when the rod is perpendicular to magnetic field and velocity is also perpendicular to that. That's how it is. Will I conduct sure shots? Yes, definitely, simply Wolf. Now moving on, look at this rod. This rod is rotating about an axis and angular speed is omega, length is L. There is an EMF created, you would have seen this formula, B omega L square by 2, very important formula, B omega L square by 2. Now my point is, where would you assume the battery? Again, let me create options. Will I assume it like this or will I assume it like this? I can't say no EMF because I have written down there is EMF, B omega L square by 2. Is it option A or is it option B? Look at the difference. This is positive, this is negative, or this is negative, this is positive. For this rod of length L rotating in this magnetic field. Come on, think about it. Hi Sunaina Mehmi, welcome bacha. Hello Anthony, nice to see you back. Oh, you're dropping for 2023, Gauri Prakash. I think you should not consider dropping so early unless and until you're very, very sure that nothing is possible. But I feel if you have done a decent bit of portion and you can at least get into some decent college, try it out. or if your aim is only IIT, no, I want that, and you think you are ready to take a drop, then go ahead with it. Okay, A. And Nandana saying B. Okay, so observe this carefully. The velocity of every point is here. It's going in a circular path, right? Velocity is there, so do V cross B. V is here, B is inside. So put your 4 fingers in the direction of velocity and then cross B. V cross B. Where does your thumb go? This way. So thumb goes this way. So definitely you can see that V cross B is this way. So hence it should be option A, of course. That's the direction of the EMF. Alright. So many times you might be asked which is positive, which is negative. This will be positive, this will be negative. Understood, my warriors? So this is how the direction of the EMF is created found out. EMF value, generally many students do it easily. Hi Titan Harsha. Now sometimes you might not have a straight wire or a rotating wire. You might have a curved wire. And if you recollect in magnetism, magnetic effects, I had told you about a property. Very interesting one. And if you recollect it, it was like when you have a curved wire which has some current passing through it and it is moving inside a magnetic field, it experiences some force. That force on that curved wire carrying current is the same as a straight wire joining the ends carrying the same current. So curved wire can be replaced by a straight wire to find the net force acting on it. Now guess what? The same logic also applies even for motional EMF. So if you have a curved wire, there is no current, remember, it's just a wire without any current, just passing. Then there is a potential difference created, EMF created. That EMF is exactly equal to the EMF as by a straight wire joining the ends. It solves many questions, it helps you in many problems. Example like this, where you have a semicircle and then let's say the magnetic field is like this, magnetic field is like this, and this semicircle is moving this way. And you are asked, what's the EMF generated across the ends? We know that this semicircle can be replaced by a straight wire, and this wire's length will be twice the radius, and the EMF will be L into V into B. L will be nothing but 2R. So it will be 2RVB, as simple as that. So that's how you can solve the question. Shreyas, after this session, what should we solve? I have this V quiz and also this assignment which is there in the crash course link. If you are not a part of crash course, join the crash course. You will get chapter wise assignments for all the chapters, physics, chemistry, maths, bio, whatever, depending on JEE NEET. Hello at LRS. Okay, moving on. Next, let's talk about eddy currents. Now, whenever we talk about eddy currents, people just memorize some paragraphs and stuff like that, but let me explain this to you in a beautiful manner. Imagine that there is a rod. Imagine that there are 2 rails. These 2 rails, these horizontal rails, are connected by a resistor. And there is a magnetic field inside the plane of the board. Fair enough? Now, if I take this rod and I move it towards the right side, you can see the motion is here. If the motion is this side, can you quickly type it in the chat box and tell me whether there will be a current created in this circuit, and will it be clockwise or will it be anti-clockwise? These are conducting rails. This is a resistor. This is also a rod which can move, which is conducting. You are moving the rod right now towards the right side. Do you think there will be electricity induced? And if it is, will it be clock or will it be anti-clock? Come on, put it up in the chat box. Hello Isha Shaul. Should I purchase AI Live course or wait till the droppers batch? Gauri Prakash, don't join the AI Live course. Please wait for the droppers batch to start. It's better to obviously join a droppers batch and not a full-time batch, because the approach is only different. Okay, anti-clockwise? Sure? Okay, let's see. Velocity is here. Velocity is here and magnetic field is inside. Do V cross B? V cross B. Where is it coming? Up. So that's the direction of the EMF. So this rod will behave like a battery. V cross B this way. So it will behave like a battery this way. So because of which you will see that if I put a battery here, the current will flow like this. So there will be anti-clockwise current. Yes, it will be anti-clockwise current which will be flowing in the circuit. Now, when this current flows through the resistor, what will happen? The resistor will create heat. There will be some heat produced in the resistor. I squared R is the rate at which the heat is created. Now you might wonder, where is this energy coming from? Because you'll be like, okay, fine, there is a battery like situation, but actually speaking, there is no battery. It's just an equivalent battery which I have shown, whose EMF is LVB or BLV. There is some current which is E by R, which is BLV by R. So if you use this current and substitute it here, you will get the rate at which the energy is lost. But the question is, where is this energy coming from? Can somebody answer this? Where do you think is this energy for that heat loss coming from? It should come from somewhere. You cannot say EMF because technically speaking, there is no physical battery present. So in reality, where is that energy coming from? So then you should think that this rod won't slide on its own. There must be somebody pulling it. Without that pull, how will this fellow know that I have to move that side? Why will it even move? So there must be some force. There must be some force pulling it. Maybe I am pulling it. Maybe I ate 2 idlis and vadas and I'm using my energy to pull it. There you go. I'm applying some force and I'm pulling this rod. That means all the idlis and vadas and all the sambar that I ate, that energy is being utilized to do work on that rod. So I'm doing some work by applying the force. Now that work done gets converted into heat. So that work done by my force F gets converted into the heat loss. So that's where it is coming from. It's coming from some external source, not from somewhere like chemical energy in the battery, because there is no battery. Okay, it is not coming from battery. It is coming from external source. Some people think it will come from the magnetic field. No, it does not come from the magnetic field. It's coming from external source. So all my energy is getting wasted in energy loss, heat loss. Now I get fed up or I get tired. I'm like, okay, sorry boss, I can't pull you. I can't pull you. My idli sambar is over. I need to refill. I'll be like, Anna, you plate idli. Okay, I'll order. So then what will happen is that I have gone. I've said bye-bye to this rod. So meanwhile, this rod has some velocity. Because all this while I was pulling it, right? All this while, hi Vignesh, all this while I was pulling it. So it has some velocity, it has some kinetic energy. So what will happen next? Think about it. There is energy which is lost. Where will this energy come from? Because I'm no longer pulling it. That's it. The rod has some velocity. Current is generated. Heat is lost. Where will the energy come from? There is only one way, and that is kinetic energy. Kinetic energy. Of whom? The rod itself. So the rod will start to decelerate, retard. It will decelerate because there is a retarding force backwards. So it will slowly reduce its speed and stop. And all the energy, kinetic energy will go into heat. That's it. After that, no current, no velocity, nothing. It will just stop over there. So if the force is stopped, the work done by the force is zero, no more work. Where will that energy come from? It will only come from the kinetic energy of the rod, which will get converted into heat. Now this problem is also the basis of eddy currents. It's the basis of eddy currents. Why? I'll tell you. In this question, what happened was, when you had a conductor which was moving in the field and it is just thrown in the field, that's it, you will see that slowly it loses the kinetic energy to the currents inside it, which will create the heat. Similarly, if I have a conductor like this thrown without any circuit, you will see current will still be formed. Here there was a circuit over here where current used to flow. You might wonder, if I just take a normal conductor and throw it, where will the current be formed? Well, the answer is the current is still formed within the conductor itself, within the width, thickness, length, breadth of the conductor. And these current loops are also called as eddy loops. What are they called? Eddy loops. And once the current starts flowing, it will obviously create some energy loss. And that energy loss comes at the expense of the kinetic energy. Hence the motion gets retarded. The current loops create heat loss in that particular conductor. This is basically coming from the loss of the kinetic energy. This is called as the eddy current loss. Understood, guys? No, is that conductor charged? No, 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 no. These lines, what are these crosses? These are magnetic fields. It's a normal conductor. You take a copper wire, or I don't know, you take a copper ball, or you take a iron ball, or you take a iron chunk. You just throw it inside magnetic field. You will see it will lose the kinetic energy. It will retard because current loops are created within the conductor. It will become hot, in fact, and that is basically the concept of electric trains braking. So trains which have large speeds, they can be braked using the concept of eddy currents. So you place a magnet close to the metallic wheels, you will see eddy currents are created, heat loss is there, and slowly it will lose all the kinetic energy. That's how it is. Cool. Thank you, Shiva. Hi Ramya, nice to see you back after a long time. Very good, Darshani. Okay. Now after this we will talk about the concept of inductors. Guys, slowly we have we have talked about eddy currents, we have talked about motional EMF. This force, Lorentz force, we have already spoken about it. The reason why I have mentioned Lorentz force over here is because there are questions where sometimes this type of situation is given and they tell you that what will be the force required to pull it with some velocity. So you have to think, there is some current. If there is some current, there is some force by the magnetic field, which is ILB. So there will be one ILB force. There will be one ILB force. There will be one ILB. This is your Lorentz force. Lorentz force, which should be balanced by this force so that it moves with constant velocity. So there could be questions where ILB concept is coupled with EMI or motional EMF. So that's why I've written it. So now let's move on to the concept of, where is it? Yeah, inductors. We'll talk about inductors and then we'll go to AC. Okay. Now to talk about inductors, let me make you understand and give you a feel of what inductors is. Just keep listening, just keep answering. You will learn all these, revise all these, concepts. Now, definitely, the approximate batch timing Gauri Prakash will be, just give us some time, in June only, somewhere in June. You get the first batch. Ramya Balaji, I'm not sure, bacha, after a few days, obviously, probably June 1st or 2nd week. Okay. Now, what is an inductor? Inductor is a device which resists not the current, resists the change in the current. There is a big difference between saying you are opposing current and you are opposing the change. What's the difference? Example, let's say, you say to your mom that today you want to go to party. Your mom says, no, you can't go. Sorry, sit inside. So that is resistance. Now, let's say, for example, today you go to the party. Tomorrow also you say that I want to go to the party. Your mom will say, no, sit down. Third day also you say, I want to go to the party. Your mom will be like one tight slap, sit down, study. So that is resistance to your motion to go to party. Now, imagine this. Today you are going to the party. Somehow you managed. You met your friends, whatever. Tomorrow, also you decide to go to the party. Imagine your mom is like, you went to the party yesterday? Yes. Okay, fine, go. Go, no problem, fine. Third day you come, I want to go to the party. Mom is like, did you go to the party yesterday? I'm like, yes. Fine, no problem, go. No problem, you go. Fourth day, you come. Today, I want to go to a movie. Wait, what did you do yesterday? You went to party? No, you can't go to the movie. Sit down. So that is resistance to change. That's what inductor does. It opposes the change in the current. If the current is there, it is like, okay, no problem. If it tries to increase or decrease, no, don't increase, come down. If it tries to decrease, no, come up. So it will always try to oppose it. That's what it is. That's the major difference between PL, resistor and inductor. Now, inductor is basically any coil or anything which can produce flux within itself and affect it. And there are two types of inductive devices that you need to understand. One is mutual, the second one is self. self and mutual. Again, let me give you a simple example just to make you understand. Imagine Pandu and Champa are there. Pandu and Champa. Champa is trying to study. There is bio exam, there is maths exam in few days. Champa is trying to study. Pandu comes, he's like, hey Champa, what are you doing? Come, let's go out. Let's go for a bike ride. Let's go for a movie. Let's eat outside. I'm hungry. God knows. Let's watch Netflix. Champa gets distracted, carried away. That is mutual inductance. Self-inductance is when Champa is sitting quietly in the room. She just opened her physics book or bio book or maths book or chem book, and then as soon as she opened her notes, suddenly one evil person within her came up, her dual mind, her inner senses came up and like, oh, it's okay, why do you want to study? Anyway, Shreyas Sir will conduct last minute revision. If you miss that also, he will conduct one more last minute revision. He will conduct one revision one day before the exam also. Why do you want to study? Chill, let's go out. Yeah, okay, come, let's go, party. So that is where you yourself are affecting your, whatever actions. That is self-inductance. So over here, you will notice that there is a coil carrying current. There is a coil carrying current. And this current will obviously create a field. And field will create flux. Imagine the current tries to change. Imagine the current tries to change. And what will happen? The flux will change. Flux changes. Call Faraday. Faraday will come. What will he say? Oh, you are trying to change? I'll create EMF. I'll try to oppose. Lenz will also come. Call Lenz also. Lenz will also come. Oh, I will oppose the change. So immediately there will be induced EMF. So that EMF will try to oppose the change in the current. And whose change is it opposing? Its own change. That is self. Now, the flux within the coil is proportional to the current, and that proportionality constant is called as the self-inductance coefficient. Self-inductance coefficient, its unit is in Henry, and the induced EMF within itself is magnitude wise L di by dt. L is the self-inductance coefficient, di by dt, because when you differentiate this, you will get di by dt. Remember, d phi by dt is EMF. When you differentiate, L is a constant, it comes outside, so di by dt remains. P by Q is also there, definitely. Now, you should know the self-inductance of a solenoid. Very important. A solenoid has a self-inductance of mu naught n square L into area of the cross section of the solenoid. N is the number of turns which are there per unit length. 500 turns per centimeter, whatever. That is N. L is the length of the solenoid, not the wire length. It's this length from here to here, not the wire length. And A is the area of cross section of that solenoid. That gives you the self-induction coefficient. Like you have capacitance of parallel plate capacitor is epsilon naught A by D. Same way you should know this as well. Is that okay, guys? Cool? Fair enough. Now we'll talk about mutual inductance. Mutual is where you will have two coils. One is called primary, second is secondary. The primary will have an actual current flowing through it, which will change, the current will change, because of which the field produced, the flux produced by it will change. And some of the flux was interfering, was piercing through the secondary coil. The moment this current changes, this flux changes, the flux through the secondary coil changes, EMF is created. And this EMF, according to Faraday's law, again is m di by dt, but notice over here EMF in the secondary is m, which is mutual inductance coefficient, into di1 by dt. I1 is the rate of change of current in the primary coil. That's what it is. That's what it is. Okay, so the EMF in another coil is mutual inductance into rate of change of current in the first coil. Yes, there will be self-inductance even in this case. So usually when there are two coils, because there is current changing here, there will be also an induced EMF back here. And because there is an induced EMF here and current is trying to change here, there will be induced EMF even here as well, self one. So two self and one mutual, but here we are exclusively focusing on the mutual coefficients. And the flux in the secondary is proportional to the current in the primary. Now the same type of device like you studied for self-inductance is also there for mutual inductance, but this time, because mutual means two things, there will be two solenoids, one inside the other. The blue one is the bigger one, the green one is the smaller one inside of it. So when you have two solenoids concentric, the coefficient of mutual inductance formula is very much similar to this one, mu naught. Instead of n square, it is n1 n2. Can you guess what is n1 and what is n2? It's the same thing. What was n? Turns per unit length. n1 and n2 are the turns per unit length as well. Is the turns per unit length as well in this case, but n1 is for the inner coil, n2 is for the outer coil. So you can see green one is the inner one, blue one is the outer one. That's why I've shaded it that way. Cool, guys? And L, be careful, is always the length of the inner coil, and area is also of the inner coil. That's why I've shaded it in green. Okay, very, very important. It's the same formula, mu naught, n square, L, area. Fair enough. No difference. Cool. Let's move on. Now, you had RC charging and RC discharging of capacitors. Same way, you have LR charging and LR discharging or decaying of inductors. An inductor is nothing but an energy storing device, just like a capacitor as well. So it can store energy, just like capacitor used to store energy in electric field. Inductor will store it in magnetic field. The amount of energy stored is given by half Li square, quite similar to capacitor's energy, half CV square. So here it is half L, which is the inductive property, into current square. Now you take an inductor, touch it to a battery. You will see, if you close this circuit, inductor, battery, resistor, the moment you close the switch, current will start flowing. The energy will be stored in the inductor, but the current won't build up instantly, or the energy won't be stored instantly. It takes some time. Reason? The last paragraph, last slide. Inductor resists the change in the current. So it won't allow the current to go up within a fraction of a second. No, it doesn't. It takes some time. So the current with time grows like this. Takes some time. Slowly it builds up. And finally it reaches a steady state value. That function via integration and applying KVL comes out to be like this. I is equal to E by R, 1 minus E to the power minus RT by L. That's a standard result which you should know. In this formula, the value L by R is also called as a time constant. Reason is that, this function becomes very simple when you substitute the value of time as L by R, because it will become e raised to minus 1 and calculations become very easy. So when the time is one time constant, when you substitute it, you will see that this current is actually 63% of the final current. 63%. So the current builds up eventually, but after one time constant, it is just 63% of the final current. After 2 or 3 more time constants, you will see it will almost be 99% or 100%, almost over there. That's the growth of the current when you connect an inductor. The idea is that the current does not go up suddenly, it takes some time. If this inductor was not there, you will see that the growth will be like this. Fat se. Nikita, no problem, join in. Hi KS Mangalo. Hi Vijayalakshmi. The second part is when you decay. That means the battery is removed, current was flowing, energy was stored in the inductor. You remove the battery and then you short it so that the current will now only go through the resistor. What does the resistor do? Heat loss. Where will the energy come from? Energy stored in the inductor. So all the energy stored in the inductor will completely be lost in heat across the resistor, but it won't happen, it won't happen within a fraction of a second. That also takes time, because inductor does not like any change. If it has to go down, no. If it has to go up, no. So it takes some time to go down. That's why the graph of the current versus time comes out to be like this. Very similar to discharging graph of a capacitor. The function while decaying is much simpler, just very similar to capacitors decaying. So the final current is initial current into e to the power minus RT by L. So this 1 minus is not there, it is just e to the power minus RT by L. As simple as that. Now, in charging part, after one time constant, 63% current was built up as compared to the final current. After one time constant. in case of decaying or the loss of energy, you will see after one time constant, 63% is discharged or only 37% is remaining. That's all. Only 37% is remaining. Okay, so these are the facts, figures which you should remember. Let's go to AC now. So most of I think EMI we have revised. We are quickly going to revise AC and then we will go to the problems. Okay, fair enough. So let's see if you guys remember all these things. First of all, AC generator. AC generator is nothing but a coil which is rotating in magnetic field. Area is A, turns is N. The EMF created is B, A, omega N. Very easy to remember. Born. Just remember the mnemonic born. Shiva, it is not very hard, trust me. It is completely vectors. AC is just vectors. Okay. Is the current built in inductor or circuit? Shruti, in which case, bacha? In the left one, the charging case or discharging? Like, what is exactly your question? Shruti, can you be more specific? Maybe I'll answer it. Okay. So when it rotates, this is the amount of EMF created. Like you can see, there is a sine or a cos function, because of which, if you draw a graph of EMF with time, it will look like a sine or a cosine graph. It will look like a sine or a cosine graph. So the maximum value, this is the peak value, is born. So plus born, minus born, plus born, minus born. It keeps varying between it. When it is this side, current is flowing this way. When it is negative side, the current is flowing the other way. So that's why it's an AC voltage. And the most important thing is average voltage. Average voltage is nothing but the value of voltage here plus 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 here upon the number of readings that you're taking. If you take it for one cycle, the average value always will come out to be 0 for a AC sine or a cos voltage, because as many positive values, that many negative values. Hence, the total sum in the numerator itself will be 0. That's very important. Also, it's very important to notice that if you use an ammeter or a voltmeter or a galvanometer to measure the voltage or current of a AC circuit, it will always show the average value, because the reading shown by a galvanometer depends on the current or the volts that are being passed through it. Hence, if the voltage increases, decreases, current increases, becomes negative, positive, negative, positive, negative, the deflection will go like this. And because the frequency is so fast, it will hardly have any time to go this way and this way, this way, this way. So it will show you the average value. So a voltmeter or an ammeter or a galvanometer always shows you the average voltage. So Shruti, is the current built in the circuit or inductor while? Oh, it's in the both, Shruti. This is the same current because it's series. The same current flows through inductor, through switch, through resistor, and the battery as well. All the devices, because everything is in series. I'm not sure, Thalapati. Okay. Next, most important value, which is the RMS. Root mean square. You have seen this in kinetic theory of gases as well, and maybe other chapters. RMS by definition is V1 square plus V2 square plus V3 square, all the values square, sum it, divide by n and take the root. That's why root mean, because average of the squares. But what does it actually mean? It means if you pass an AC current, there is some heat which is generated. AC current generates some heat in the resistor. But every time the current passing is different. So every time the heat generated is different. So over a cycle, some amount of heat is generated. Now RMS is that constant current or voltage which produces the same heat in that same resistor as that of that AC current. So it's basically the DC equivalent of AC. So when I say that there is an AC current passing, I'm not able to understand how much is that current or voltage. I'll be like, hold on, how much heat is that AC generating? Okay, this much. Okay, you tell me that DC current which will generate the same amount of heat. So that is called as the RMS. As simple as that. Okay. Now the RMS value for a sine or a cosine voltage is V max by root 2 standard, or RMS current will be I max by root 2, again standard. So that value you should know. Root 2 value is 1.414. 1 by root 2 value is 0.707, which you should also know. Useful for solving questions. We need not connect a resistor, Shruti. Resistor is anyways there. Even a wire has some resistance. So that R is basically a depiction of the resistance of the battery, of the wires, and maybe the coil itself of the inductor might have some resistance. That's it. Talking about AC voltmeter, ammeter. So an AC voltmeter, that means when you want to measure AC voltage, because we know that our conventional ammeters which are based on deflection cannot work because it will always show zero reading. So to measure AC, you need a special device, sometimes based on heating effect. So I can measure how much heat is created, and based on that heat, I can measure how much current or voltage is there. So these are basically called as hot wire instruments, because you are indirectly measuring the heat to figure out how much voltage of AC or how much current of AC is in that circuit. Understood, guys? Fair enough. So these are basically called as hot wire instruments for AC. Now let's talk about phase. Now phase basically tells you whether you are in sync or you are not in sync. Now remember, whenever you draw charts or graphs, one of the two kinds of charts that you usually get is a time domain graph or a chart, and second one is called as a phase domain. Time domain means I want to know what is the value at this time, what is the value at that time, when is it this much. So that is called as a time domain graph. Notice over here, current is varying like this. At 0, the current is also 0. Current increases, 0, negative, 0, positive, negative. So it's a I naught sine omega t graph. I naught is the max value. Sine omega t is the variable oscillating term. Omega is your angular frequency, standard. Okay, look at the voltage graph. Voltage over here starts from some random value which is not 0, and then it comes to 0 after some point. You can see after one time period of the current, if you go up, one oscillation starting from here to here is not done, it has been shifted. So they are not in sync. When there is a crest over here, there is no crest. When there is a trough here, there is no trough. They are not in sync. Okay, so basically there is something called as a phase difference. That's why in the EMF equation, E naught is the max value, sine omega t is there, but there is plus or minus phi, because there will be something called as a phase difference, which you know from the waves chapter, like two waves which are not in sync. Hello beauty buddies, welcome. Okay, now once you understand this much, remember in SHM chapter, oscillations chapter, if you take a particle going in a circular path, then the shadow of it performs what? Put it up in the chat box. When a particle performs circular path, the shadow of it performs what? The shadow performs oscillations, basically a simple harmonic motion. Now, this is also a kind of oscillation. So I want to know that circular motion which will produce this oscillation. So that circular motion is represented on the phasor diagram. It's represented as the phasor diagram. Okay, Nandana, is that mean opposite? I mean, I'm not getting you. What do you mean by that? Is that mean opposite as in what mean? Opposite to what? So look at this yellow diagram first. This is the yellow phasor, with the yellow color one is the phasor of the current. The length of the phasor is always the amplitude of the voltage or the current. The length of the voltage phasor is always the amplitude of the voltage or current. Again, same thing. Now if you look at this, at time 0, when you just started it, the current phasor is horizontal. If light came from there, or think of the shadow on the y-axis, or think about the y component of the yellow vector, the y component is 0, and that is also seen over here. There is no value of the current at t is equal to 0. As this yellow line starts moving like this, you will see there will be a y component of it which will grow, and that's the reason why you will see the value of current increases. After it passes this side, after it passes this side, the Y component reduces. So you can see the current reduces. So in a phasor diagram, a phasor whose length is the amplitude rotates with some angular speed, whose component gives you the value of the physical quantity. So what is a phasor? Phasor is an imaginary term, imaginary concept to help us understand the circuits, to help us add, subtract these waves or these quantities. Remember, whenever waves come, there is always vector addition. So phasor diagram gives you the understanding of how to add them, who is behind whom, who is lagging, who is in front, etc. So phasor diagram is basically that circular motion whose shadow or whose component is that oscillation, because a circular motion shadow is an oscillation. Make sense? Understood? Thank you, beauty buddies, so much. Okay. Now, since I told you there was some difference between the voltage and the current. Current started here early. Look at this voltage. Voltage has some negative value. That's the reason why I have shown the green color arrow mark a little bit below, because when I start, take a snapshot, t is equal to 0, start the time. The voltage graph is here. You can see the Y component is negative. That's the reason why it starts from here. After some time, when the green arrow mark comes here, the Y component will be 0, so it becomes 0. So there is this phase difference over here, that is phi, the same phi as shown over here. So the voltage is behind the current. Current is moving ahead of the voltage. That's the phase difference. Intention. First of all, don't be in tension. This is not full concepts, this is revision concepts. There's a difference. Oh, Shruti, yep, definitely. Just give me a moment. Okay. One last thing and then we'll take a water break. Now, in case of DC, the power lost is I squared R, but in AC, it is not I squared R, it is I RMS squared R. That's the difference. It's always the RMS current squared R. Number one, power lost. And if you want to write it in terms of voltage and current, don't write V into I. No, V into I is not the power lost. VRMS into IRMS into cos phi. Cos phi is the power factor, where phi is the phase difference. Power factor can be anywhere between 0 and 1. If it is 0, that means phi is 90 degree. So there is a phase difference of 90 degrees between voltage and current. If phi is 0 degrees, then cos is 1. That means voltage and current are in sync. Ishan Lohani, well, for 11th standard, so let's have a 1 minute water break, guys. Meanwhile, I can just talk to you. Ishan, for 11th standard students will not have the long-term batch on YouTube because it's already done last year. So start watching that long-term batch lectures. It's there in the playlist. I'm pretty sure you are aware of it. So start watching that, but we'll have problem solving sessions separately or some kind of tricks and strategy sessions as well. Is phi going to change? Bethana, generally phi does not change unless and until you change something externally. ComEdK, Shiva, just give your mock test for ComEdK. Apart from that, syllabus wise, it is almost the same as JEE mains or any other exam. Hello Vandana. How to solve Cengage fully? Cengage, first of all, not a good book, Gautam. So difficult to solve it completely. There's no need also. Yeah, okay. So Ishan, don't worry, we'll be doing problem solving series. And Ishan, also, whenever there is a 11th standard one shot or anything like that, attend it for free so that, you know, at least those problems you can solve. You can see newer and newer problems, because generally in my sessions, I rarely repeat any problem, be it 1 year back also and even now, you will hardly find maybe 2% or 3% of the problems would have got repeated. Something will be different, 100%. So you'll always learn something new from the problems. Yes, Shiva. So when you prepare for JEE, you automatically prepare for CET, ComEdK, VIT all these exams. Hi Varsha. Okay. Let's move on. Okay, last few things. Wow, what is this slide? This is a slide where love is above all, is it? Okay. Inductor, resistor, capacitor, LCR circuits or LRC circuits connected to an AC source. Now this is the main slide. This gives you everything about the LCR circuits. When, forget guys, remove all this nonsense, don't worry about this. When you have a supply which is AC giving some EMF, because all the three are in series, what will be same guys? Come on, put it up in the chat box. Hello Maram Ritika, good evening bacha. Hello Enlight's product. Oh my god, black heart. First of all, everything is black. I can't see your black hearts. Make it white. Thank you Varsha, means a lot. Oh my god, you just made my day Varsha. Okay, so it's in series. Yes, so that's why the current is the same. All the components have the same current, but the problem is the voltages won't be same. Now see, there is one fundamental difference which you need to realize between AC and DC. DC is scalar, AC is vector. The moment you make this thing enter in your head, then you will not make mistakes. Example, say there is some kind of device, DC device, DC voltage, DC current. There is 5 volt difference here, there is 2 volt difference here, and there is 1 volt difference here. So the total difference of voltage between these three devices will be 5 plus 2, which is 7, 7 plus 1, which is 8. So 8 volts is the total voltage. But for AC, never even think about it. Never add voltages. No. Reason, they might not be in the same phase. They might not be in the same state. If they are not in the same state, it's not being fair to add them. So to be fair, you have to do vector addition. So the total voltage is the vector sum of the voltage of inductor, resistor and capacitor. The moment I say vector addition, students get confused. Sir, voltage is a vector? What are you saying, sir? I thought voltage is a scalar. Yes, it is a scalar. But in this diagram, which I just told you, which is the phasor diagram, this is treated like a vector. These are vectors. In a phasor diagram, these same arrow marks become vectors because they can be treated like vectors to solve the problems. That's the whole advantage of phasor diagram. Some of you are asking, sir, why do you need phasor diagram? It helps us solve problems like vectors, and vectors makes life easy. Okay, that's number one. Everybody clear about this? Very good. Hello Kajal, welcome. Maram, 150 is a decent score. I would like to push you to 180 to 200. I think you can in the last 1 month. Rajat, yes, I'll be doing sessions for BitSat as well. Now, having said that, voltage across resistor, inductor and capacitor, they are not in the same phase. So we need a phasor diagram. So look at this diagram, forget everything else, not needed. Turn a blind eye to everything. Just look at this and don't look at the green lines also, just look at the yellow line. The yellow line is the current line because the current is the same through all of them. So current will be a common phasor for all the three devices. Same current, they are in series. Cool, bacha? Very good. Now, okay. Talking about the voltages across the resistor and the inductor and the capacitor. Always remember, for a resistor, you might think of it like a evil, but the voltage across the resistor and the current across the resistor are always in phase. That means, if you go back to this slide, here there was some phase difference. For a resistor, the voltage and the current go in sync, go in tandem. So that's the reason why VR and the current are shown in line, because they are in phase. They are in phase. Thank you, Asha. Okay, this is how much can I score for NEET physics? A lot, Tushar, a lot. Ankit, come on, last 1 month, do it. Last 1 month. Okay, now this much is here. Talking about voltage across inductor and capacitor. Usually what happens, people get confused. Who leads whom? Who is ahead of whom for inductor and capacitor? That's the reason why I have put up this statement, love is above all. L, inductor. L, inductor. So always inductive voltage comes on the top, capacitor comes below. That's all, as simple as that. So you can see inductor voltage is ahead of the current because this entire thing goes like this. It goes like this. So inductor's voltage is always ahead of the current, whereas for capacitor, voltage is behind the current by 90 degrees. Hello Pallavi, hello, thank you Pranav. If I'm consistent, you too should be consistent, bacha. Because then nothing can break and nobody can stop. If both teacher and students are consistent, that's it. You can create marvels. So now we have completed the basic part of the phasor diagram. Resistor voltage, inductor voltage, capacitor voltage, all three will move together like this, and current and voltage across R is in tandem. Inductor is ahead of current, voltage of capacitor is behind the current, number one. Now, since I told you these are all like vectors, if you do vector addition, you will get the total voltage E naught, which is across the entire set of LCR, which is the applied voltage. And that can be done by first taking care of VL and VC, because they are opposite. So whenever two vectors are in line, you'll first take care of those vectors, like you have done in even your free body diagrams. Like you draw a free body diagram like this, mg sin theta is here, friction is here, tension is here. First you take care of these things, then you worry about other things, right? So same way, VL and VC, if you take care of it, VL minus VC will be the net vector here. VR comes as it is. These two vectors addition will be like that diagonally, and you can find it out by Pythagoras, obviously, triangle law, parallelogram law, whatever you want. So this will be this square plus this square will be the net square. This is the net EMF, which I can just put it over here. And like you can see, the net EMF and the current have some phase difference. There is some phase difference between them. Is that clear, bacha log? Understood? So that's the phase difference. So this is how you get the formula. You don't need to by heart this. You should just know love is above all. Resistor is always in sync. Capacitor is obviously behind. So it's just a vector addition of all of them. Nothing great. Varsha, is JEE possible if you start from the scratch? Varsha, are you 2022 student? If you are, what scratch? I mean, like at least board level is done, Varsha. It depends on that. Definitely, Ankit, you should be. Okay. Hi, Buddy's Kitchen. Can we add all the potential drops at a particular instant provide EMF? Yes, Avi, you can add the instantaneous EMFs to collectively to get the net instantaneous EMF. That is valid. But usually when we give voltages, they are all RMS or peaks. So that you can never add. Varsha, you should tell me what scratch is it exactly. Maybe you can leave a comment after the video or just wait till the video ends. I'll help you out. Okay. Now, this is not just valid for voltages, this phasor diagram. This is also valid for something called as the resistance. Now you might be wondering, sir, what, resistance also is also a vector? Yes, resistance is also like a vector. I'll tell you how. You might be wondering, there is only one resistor here. What about inductor and capacitor? Well, inductor and capacitor are not resistance, but they can oppose the current also. Yeah, inductor opposes the change in current. That's another story. Let's get rid of that. But inductor also opposes current, especially AC current. So the equivalent resistance of an inductor and a capacitor is not called resistance of a capacitor and inductor. It is called as reactance, X. X is called as the reactance. Is that clear, bacha? Okay. So you will be like, sir, why not just call it inductive resistance, capacitive resistance? Have you ever wondered? Have you ever asked? Why is it called reactance? I'm not interested in the meaning of that word. Why a different name? Sorry. Pradeep, yes, true. Varsha, if you're talking about scratch and from board level, I would seriously advise you to probably think of a drop for 1 year. If you really want to crack IIT, that will be good. Or else, if you think you can crack CET exams, then I feel you should prepare for the CETs and CUETs and the Comet case and those kind of exams. No. Students prepare for 3-4 years, but that is not needed, Pradeep. 2 years, not 1, 2 years are enough. More than enough to even get All India rank 10 or 100 also. Okay, fair enough. Now, why is it called reactance and why not resistance? Because resistor is the only device which causes a loss in the energy, whereas capacitor and inductor always store the energy. That's why the new name reactance. Because although it opposes, but it has some good thing. So why put it in the evil category? So we gave a new name called as reactance. That's the only reason for that. Okay, now we know that inductor and capacitor have resistive property which is called as reactance. For inductor it is omega L, for capacitor it is 1 by omega C. That's it. CG, you should watch one of them as recorded and you can fast forward the recording, CG. Okay. Yes, Jesse, I do recommend drop for 1 year if needed, definitely. Now, talking about the next part, since I know the reactances, XC is 1 by omega C, XL is omega L, and R is R, obviously. Just like you drew the voltage vectors VR, VL, VC, you can draw a similar triangle, resistance in line with VR, XL in line with VL, and XC in line with VC. That's it. It's the same thing. R, XL, XC, VR, VL, VC. Same thing. And you can add them vectorially. XL minus XC will be taken care of here because these two are in line. So this net will be XL minus XC. R comes here. The resultant, oh, I can't call it resistance, I can't call it reactance. So I define a new term called as impedance. Shruti, it comes via derivation, Shruti. I mean, it's not like via experiment. Mathematically, there is a derivation for that as well. No, Sriji, I can't, bacha. That's the reason why we provide recordings. Okay. So this is called impedance. Impedance is the total resistance plus the reactance of the circuit. Total thing of the circuit. And again, Z will be, or Z square will be this square plus this square. So XL minus XC whole square plus R square. Done, done, done. That's what this is. Okay. So we have done voltage. We have done, what is this? Resistances, impedances and reactances. There is only one thing now, and that's Ohm's law. Ohm's law says voltage is current into resistance. Voltage drop is current into resistance. So if you look at this part, resistor, the voltage across this is VR, current is I, resistance is R, so VR will be IR. Simple, V is IR. For inductor, the voltage drop is VL, so VL will be I into that resistance which is XL. It's XL. Okay, be careful. That's it. So VL will be I into XL. That's it. Same way, voltage across capacitor will be current into resistance. Resistance is XC. Now, if for this V is IR, if for this V is I into resistance part, if for this voltage is I into resistance, for the whole circuit also it should be valid. And yes, it is. For the whole circuit, the voltage is E, the current is same. So total E will be current into Z because Z is the total resistance. So total voltage is current into Z. That's all. Understood? This is very, very important. Yes, Shiva, it is easy. My coaching institute was not taking minimum care. They focused on local state exam. Please give suggestion. Abhi, for JEE, you should pick up some JEE PYQs. Number one, attend my JEE courses here on YouTube, obviously. Third thing, attend my JEE crash course where I am only teaching, solve the assignments and give the mock test. These are the 4-5 things which I can tell you. Please do it in the next 1.5 months for till the second attempt. That's all. Varsha, you're not aiming for IITs, you're satisfied with NITs as well? Still tricky because you said only boards, you're not thought about this thing. I would suggest, Varsha, give few mock tests and see what is your score and then tell me. Tell me what is your score based on the mock test. Accordingly, I will adjust and tell you. Okay, you can put your score in the comment section or ping me on my Instagram handle. Anything will do. I'm not through with the concepts taught in 11th. Should I watch Nursery series? Yes, Jesse Rajon, definitely. Abhi, you have taken crash course, then best bacha. You are already getting the assignments. Please go ahead with it. Solve all the assignments, solve all the mock tests, attend all the classes, class notes, everything along with the YouTube classes. notes, everything, you will get it. Okay, last two slides, let's do this quickly, guys. Now, there is something called as resonance, where this voltage aligns itself with the current. Voltage aligns with the current, so phi will become 0. That's when you will see that the current in the circuit is maximum, and then it is said to be resonating. So, when the voltage aligns itself with the current, and that can only happen if the voltage of the inductor and capacitor are equal and opposite and they cancel. So, there is only one voltage because they have all cancelled. Phase difference is 0. Power factor is 1. Even if you take the resistance phasor, XL will be XC, the Z will be equal to R. There is no phase difference. Z will collapse onto R. XL is XC. So omega L is 1 by omega C. Omega square will be 1 by LC. So omega N will be 1 by root LC. This is called as that frequency when the phase difference is 0, power factor is 1. Power factor means the power losses, the power delivered is always maximum. So if you draw a graph of current versus current versus frequency of that source, you power it up with different frequencies. There is one frequency for which the current in the circuit is maximum. That phenomena is called resonance. That frequency is when it matches with the natural frequency of that circuit, which is given by 1 over root LC. All right? Okay. Guys, don't worry guys, I will talk with you, probably general talk and all that. I know a lot of you have a lot of issues and I understand that. Obviously each student is different. That's why I'm conducting a casual talk session tomorrow. So just wait for it. Probably I'll answer all your doubts. Now that you understand that the current is maximum only for a peculiar value of the frequency of the AC source, right, shown over here. For all other frequencies it is less. There are two special values which you should know, and that is, here the power is maximum, power factor is 1. There is a value of the source frequency for which the power is half of the maximum value. These frequencies correspond to half the maximum power. This is half the max power that you can get in the circuit. So if you are in this frequency range from F1 to F2, your power will be at least 50% of the maximum value. Power factor, I explained it abhi long time back over here. Where did it go? Here. Power factor is this. P loss is Vrms, Irms, cos phi. This cos phi is called as the power factor. When phi is 0 and the phase difference is 0, cos 0 is 1. That means the voltage and the current align itself together. They are in the same phase. Inductor and capacitor's voltage cancel. That's all. Okay, fair enough. This range, the width of the frequency, is called as the bandwidth. So a LCR circuit always has a bandwidth. So that bandwidth tells you how much amount of frequency you will get, a good 50% at least power delivered in that circuit. So that is called as the bandwidth, and the bandwidth divided by the natural frequency is also called as the Q factor. There could be direct questions on that, as simple as that. All right guys, cool enough? Okay, last slide. Transformer. Man, transformer just reminds me of that movie always. I don't know why. Is it me or is it you? If it's you too, then I am happy. Okay. Yeah, I agree. It's not easy to be cool. I'm getting 100 marks in mock test. Can I get 150 plus in 25 days? 150 plus. You need to please do those high weightage topics. If you are getting 100 marks, that means there are a lot of concepts which you have missed or skipped. So you need to work on that. I mean, half power loss is basically just a standard value that, I know that maximum power I can get is, let's say, 100 watts. I at least want, it's just a mental thing, I at least want half of the maximum power. So that range is called as that half power range, which starts from f1 to f2. That width of the frequency is called as the bandwidth. You can make your own bandwidth. You can say, who is that? Abhi can say that, no, I want at least 70%. So you will have a different bandwidth. It's just a personal choice. That's all. Okay, cool. So let's do this. So guys, tomorrow, yes, like James Burke said, I'm doing a motivation session, 7 o'clock, but that's a quick one. And general casual talk at 5 o'clock on this channel. Okay, so a transformer always uses AC input and converts it into AC output. The advantage of a transformer is that you can increase the voltage at the expense of the current, or you can even decrease the voltage at, again, increasing the current. So it's inversely proportional indirectly. So you would have seen transformers outside the house which convert high voltages back to your normal household voltages of 220 volts or whatever, 110 volts or whatever it is. Now, in the transformer you have two sides, the primary and the secondary side, and the entire concept of transformer is just based on mutual inductance, which I just showed you over here. Mutual inductance. This one. There is a primary coil, there is a secondary coil. The primary coil creates some magnetic field. That field will pass through the secondary coil. If there are variations in the primary, there are variations in the secondary, which creates EMF in the secondary. That's all it is based on. And you will see that whenever you pass AC current here, these flux travels, all these flux lines will travel through the secondary, which induces EMF according to Faraday's law, and that's why you get an AC output. Basic derivation which will tell you that secondary EMF by primary EMF is secondary turns, these are the number of turns, upon the primary turns. And an ideal transformer is a one where the input power is equal to the output power. And real transformers also have very little loss. The losses typically range from 1 to 2%, max to max 4-5%. So you can say the efficiency is pretty decent. So input power is output power. So E1 I1 will be E2 I2, because of which E2 by E1 will be I1 by I2, and hence if I put it over here, you will see E2 by E1 will be N2 by N1, but it is I1 by I2. So that's an inverse relationship of current. That's the reason why I told when voltage increases, current decreases, and when voltage decreases, current increases. That's inversely related. Okay. Okay. Fair enough, guys? Awesome. 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 Now, step up transformer is where the voltage increases, step down is where the voltage decreases. That's pretty much standard. So that's all that is there in transformers that you should know. Go through the theory, the construction, materials used, lamination, all those things are there, which I'm pretty sure you can go through. So I think it's a good time to start some questions. So here is the first question coming up on your screen right now. Is there a case where input and output current are equal? Yes, Abhi. That is called as an isolation transformer, where the input and output voltages are same. It's just meant to isolate two different circuits and is meant to protect one side from the other, because there is no physical contact there is no electrical contact between the two circuits. So that's called as an isolation transformer. How many questions are there? I don't know, quite a few. Yeah, now I started questions. So always theory, I feel like revising the theory because many students come for revision. So it's fine. I mean, if you want to skip the theory and just attend for the problems also, it's fine. But you should attend for the problems for sure. Even if you miss theory, it's okay. Some students are like, okay, sir, I know it. Why do you want to do it? Fine, no problem. But at least attend the problems. You cannot think of problems as an option. Option A. Everybody saying A. Siva doing balle balle. Let's do this. The magnetic flux linked with the circuit of resistance this much increases by this much in from this much to this much, the amount of induced charge. Okay. Now, sometime back I told you about EMF being nothing but del phi by del t, and current is nothing but EMF by resistance, and current is nothing but how much charge flows in how much time, and this is nothing but is del phi by del t. So del t cancels, so del q is 1 by r del phi. So the question says find the value of induced charge So del Q will be 1 by R, which is 1 by 100, into del phi means 60 minus 10. 60 minus 10, so it is nothing but 50 by 10, which is nothing but 0.5. Is that there as an option? Yes, it is. Chemistry है क्या? Chemistry नहीं है. My God, क्या बात है? Motivation. This guy came as if he came for buying some onions or potatoes. Sir, chemistry है क्या? आलू है क्या? कांदा है क्या? My God. क्या बात है? Next question. Wow, this is an interesting one. My favorite word. Many words are my favorite. You will see if you attend my classes. Shown in the figure is a circular loop of radius r, resistance r, and the variable magnetic field of this much. Wow, it is changing with time exponentially. Crazy. Is established inside a coil and the switch is closed. The electrical power developed right after closing the switch is how much? Let's try to do this question. There is flux going through the coil and that flux will change because the magnetic field is changing. So in order to find the the power, I think to find power I need voltage, and to find voltage I need to use Faraday's law. There is no other option. So the EMF generated, which is d phi by dt, where flux is nothing but B into A, cos will be 0. Reason field and area vector both are parallel, so cos 0 is 1. Area is same, so just bring that area outside. So it will just be pi r square into dB by dt. Now over here, dB by dt, B naught is a constant. So just think about it. It's B naught into e to the power minus t. So, oh, by the way, this is also minus. This is minus because of that Lenz's law. Fine guys, I am only interested in the magnitude, no issues. So this will become minus pi r square. Derivative of this guy, first of all, B naught comes outside. Derivative of e raised to x is e raised to x, but this is e raised to minus x. The derivative of e raised to minus x is minus e raised to x. So it will be minus e raised to minus t. So minus minus becomes plus, so pi r square B naught e to the power minus t. Now right after closing means time is equal to 0. So the initial value E naught will be pi r square B naught e to the power minus 0. E raised to 0 is 1. So it's just going to be pi r square B naught. Pi r square B naught. Fair enough. Now this much is done. Alright. Now what is the asked? What is the power? Oh, power? Power will be V square by R. So power will be V square by the resistance. So just square this whole thing and divide it by resistance. So it will be nothing but pi square R raised to 4 B naught square divided by R. That's it. Do I have an option like that? Do I have an option like that? I think so. B naught square pi square R raised to 4 by R. So it seemed difficult, but it was just based on the derivatives concept of e raised to minus x. That's it. Simple. EGPG, lemon squeegee. Fourth option. Very good. Excellent. Let's move on. The variation of induced EMF with time t in a coil if a short bar magnet is moved along its axis with a constant velocity is. So this is a coil. This is the axis. So the question is, what will happen if you move a bar magnet along the axis? This is North Pole, this is South Pole, you are moving it. Then you bring it from this side like this. This is the South Pole, this is the North Pole. It's coming like this. What do you think the current will look like, or the EMF graph will look like roughly? So let's start this chapter now. Will it be useful? Sanju Jerry, oh my God. Sanju Jerry, if you have started the chapter now, if you know the formulas, concepts, then okay. Then look at the problems, else it will be a problem. Okay, I knew this. I knew many students will make a mistake. Shikhar saying C, Shruti, Darshini, everybody saying C. I'll tell you what, it is not C. Because, see, observe. When this magnet is approaching this coil, the coil will not like it according to Lenz's law. It will oppose it. It will repel it. So how do you repel? By creating a north pole of the coil here and south pole here. So magnetic moment will be created like this. If magnetic moment is created like this, a current will be induced in this direction. This will be the direction of induced current when the magnet is approaching. When it starts going away, the south pole is going away, the coil will not like it, coil will pull it back. There will be an attraction. How do you create attraction? By creating north here and south here. The coil will generate north here to pull the south pole because it does not like any kind of change. When it goes away, it pulls. If it comes close, it pushes it away. So the magnetic moment will be created here. If you use your right hand, the current will be induced in the exact opposite direction. So the direction of the current has reversed. That means the sign of the current or EMF also has reversed. There is only one such graph where it reverses, and that is here. So if it was negative, it has become positive. That is option B. It's not D, it's not C. Suggestion as in like for what are we? Oh, no problem, Sanju. Definitely. Okay? This is very, very important. Very, very important. Okay? So this is how you should realize that, oh, none of these graphs will be correct. No. Except for B, none of them are correct. It feels that it should be correct, but it is wrong. Alright, we have a square coil of side this much centimeter having this much turns, rotated with some speed in a field perpendicular to the direction, and EMF induced is this much, magnetic induction is. The moment you see this question, one thing that should click in your mind is that this is a question on AC generator. This is a question on AC generator, because in AC generator also that EMF was similarly like this, BA omega n born sine omega t. Now comparing that, you notice that born is nothing but 200 and this omega is nothing but 100 pi. Just comparing. Now it's just a matter of substituting the values. Born value is 200. What is B? The EMF induced in the coil. Acha, we have to find B. Okay. What is area? Area is basically side length is 25 centimeter. That means it is 1/4 of a meter. That's the side length. So the area will be 1/4 square. That's the area of a square. So 1/4 square into omega. Omega is 100 pi. All right. Into n, number of turns is 1000. So 10 to the power 3. That's it. Now solve it and see what do you get. Come on, rearrange this equation, see what you get. So B will be equal to 4 square is 16, 16 2s are 32. The whole thing divided by pi is there. 10 to the power 5 is also there, correct? Oh, 32 and this 10 to the power 2. Because 16 into 2, 32, these two zeros is 10 to the power 2. Now this I can write it as 32 divided by pi is 3.14 and this is nothing but 10 to the power minus 3. Now notice this value is roughly 1/10 because 32 is very close to 31.4 also. 32 and 31.4 very close by. 31 by 3.1, come on. Oh sorry, I wrote 1/10, my bad. 10 times. Sorry. 10 times. This is 10 times, roughly 10 times. Correct? So 10 into 10 to the power minus 3, that's approximately 10 to the power minus 2. That's the answer. Teslas. Do we have it somewhere? By mistake I wrote it as 1/10, sorry guys. So this was 10 to the power minus 2. Yep, option D it is. Midnight session. Varsha, I wish I can take midnight session, but I'm not a night person. I sleep by 11 o'clock. I wake up by 6 o'clock. I go hit out, work out, run and do all kinds of exercises. 7 o'clock, by 8 o'clock I'm back. 8:30 I'm all fresh with my breakfast, everything done. So I feel very sleepy and very tired. Yeah, because of all the exertion that I do. Okay, so moving on to the next one. B1 and B2 are the two bulbs. Resistor R and inductor L is also there. When the switch is turned off, then which one will die promptly? Promptly means fast. and some delay means slowly. Let's do this. Yes, I had done thermodynamics a long time back, midnight. Yep. Once in a while I'll do, but not every day. I'm solving the PYQs by just taking me 6 to 7 minutes per question. Please give me an advice. Maybe 6 to 7 minutes is fine, no problem. If you're taking that much time, because PYQs are good, that means you have not solved enough variety before the PYQs. Okay? So usually that time reduces when you have good calculation speed, you have solved enough variety, and because you have solved a question by multiple approaches, you know how to solve it the moment you see the question. So when you know how to solve it the moment you see the question, that means you have solved enough variety and solved a question by multiple ways, so you know which way to approach it. And once you know how to approach it, because your speed is good, you will finish the question also in time. So all these 3 parameters are required. Okay, now inductor always opposes the change. Always opposes. What does it oppose? The change in current. Current was flowing, you turned off the switch. What will the current try to do? It will try to come down. So in an inductor, we know the current comes down gradually, whereas when there is no inductor, it comes down instantaneously. That's what will happen in the resistor case, whereas in the inductor case, it will take some delay. Hence, you will notice that B1 will die instantaneously, whereas B2 will take some delay. I don't know, looks like you're not seeing the 2021 paper, 2022 paper. You see that? My God, it is ridiculous. They have asked, is the focal length of a convex lens positive or negative? That kind of question came. I was like, what is wrong? Yeah, there are difficult questions also, but average level was super duper easy. Next question. 2 coils X and Y are placed in the circuit such that the current changes by 4 amperes in coil X and magnetic flux changes by 0.4 Weber in Y. The value of the mutual inductance of the coils is, okay, this one is easy actually. You can do that fatafat. Mutual inductance. So flux change is given, current change is also given. So flux in a second coil is mutual inductance into current in the first coil. Hence, del phi in the second coil is mutual inductance into change in the current in the first coil. Now, look at this. Del phi, do I know it? Yes, 0.4. Mutual inductance, I don't know. Del I think it is known, 4. So what is M? It is nothing but 0.4 divided by 4, which is 0.1. 0.1 Henry, option D. Done, done are done. Yep, it is. Cool. So flux is Mi, change in flux is M into delta I. Just solve it, you'll get it. Next question. A group of electric lamps having total power rating 1000 is supplied by an AC voltage this much, 200 sine 310t plus 60 degrees. Then the RMS value of the current is how much? Current is asked, voltage is given, power is given. So there's only one formula which will help me, and that is the power loss is VRMS into IRMS into cos phi, which is the power factor. The power is given to be 1000 watts. So let's just put 1000 over here. RMS value is not given, but from this equation, this is max, and max divided by root 2 will be the RMS value. Right? Max divided by RMS, root 2 is RMS. So what is RMS? It is 200 divided by root 2. IRMS, I do not know. Cos phi, I can find it from here. Phi is 60 degrees. So just put 60 degrees over here. So these two zeros go, root 2 goes over there. So 10 root 2 is 2 times IRMS. Cos 60 is half, 2 goes. So IRMS is just 10 root 2. 10 root 2, which is option B. Done, done, done. No, Priya, I did not have. Oh, I had my dinner just before entering the class. I just had some biryani. I ordered it from Zomato. Aditya, I did PYQs of this. What I noticed is a level of questions in 2021 was pretty easy as compared to 2019-2020. Will the level of questions No idea. Nobody can tell. There are a lot of videos. You can waste your time on YouTube. Will the level of difficulty in 2022 be easy or hard? There are a lot of YouTubers out there who made some videos. We have never made such videos. Okay, I don't think we'll make it also. Okay, you can. That's just to waste the time. Sir, completing one chapter taking 2 weeks, sir. How to complete fast? Completing one chapter taking 2 weeks. Hi Pi, are you preparing for 2022 or 2023? You tell me. Accordingly, I will advise. Primary and secondary coils of a transformers have 50 and 1500 turns respectively. The magnetic flux in the primary is this much. Phi is in Webers. The time in seconds, T is time in seconds, phi is constant. Output voltage in the secondary is how much? Then it is fine only. Hi Pi, that is okay. 2023, no? That's okay. 2 weeks, slightly on the above average side. Slightly on the above average side. That's most likely because you don't have a very good timetable or a schedule. So or maybe you have not made one. So make a schedule and a timetable. It will work well, and study from H.C. Verma. The class notes, don't have to refer 100 notes. Stick to few things. It will work out little bit easier. Have a pattern, follow a pattern and a regular flow. You will see that the time reduces. So primary coil's flux is given. And it's a transformer. If I know the primary voltage, I can find the secondary voltage as well. How do I find primary voltage? From flux, Faraday's law. So primary voltage will be d phi 1 by dt. I'm just interested in the magnitude. So the rate of change of flux will be d by dt of phi naught plus 4t. Derivative of a constant is 0. Derivative of 4t is 4. T's derivative is 1. So it will be 4 volts. Now what is it? Nothing is there. E1 by E2 will be N1 by N2. So E1 is 4, E2 I do not know, N1 50, N2 15000 goes. This will become 30. So E2 will become 4 into 30, which is 120 volts. Do I have 120? Yep, I have. Option 8 is. Yay, there you go. Done. That's it. Hello Deepthi, Mohan Rao. Thank you so much. Thank you so much, dear. Does 12th marks really matter like to admission to NITs? No. Varsha, you are a lucky batch, lucky generation, COVID batches. No need of 12 standard marks for NITs. Yeah. Okay. Done. There you go. Moving on. Next question. 120 done. RMS value. Oh wow, this is a good question. RMS value for this given graph is. I know what many are going to say. Sir, so simple. No, V naught by root 2 only. No. Be careful. Is it or is it not? It's not a sine graph. It's not a sine graph. Be careful. So you need to derive it. There is no other option because that value of V max by root 2 comes by derivation. Hari, please don't disclose my secrets, bacha. Then people will not concentrate on the board. They will concentrate in the reflection. Hai na? Okay. So let's try this out. This is one time period. This is one time period. Hai na? What is the definition of RMS? It's that constant current. It's that constant current which will produce the same amount of heat as that of a AC circuit. I need a constant current. So let's think of a resistor. Okay, let's think of a resistor through which the current is flowing and some heat is generated. There is some voltage also across the resistor. So in this one cycle of AC, how much heat is generated? Let's talk about it. So heat by AC in one cycle will be only generated from here to here because there is no current here, only from 0 to T by 2. So can I say it is the power loss rate into T by 2 because half the time was not even, there was no current. There was no current. So it's just generating only for half the time. So the rate at which it will lose power is V naught square by R V naught square by R, that's it, into T by 2. Fair enough? Okay. Now, the heat by DC in one cycle period will be, so if it's a DC, the voltage, the heat loss will be power lost in the DC into the time. The time is total time. It's not my fault that in AC, half the time you did not create any current. That's not my fault. It was not there. I can't help it. Okay. So in DC, if I pass some current constantly for some time, how much heat loss will be generated? It will be power into time. Power will be V square, this is V RMS by the way, V RMS square by R into T. Now according to the definition, this and this must be same. This and this must be same. So equating both of them, what will I get? V naught square T by 2R will be V RMS square into T divided by R T goes. So taking roots, so V naught by root 2 is VRMS. Now I know what people will think, sir, I think you're gone mad. You have just unnecessarily wasted our time by doing all this. Anyways, I knew, sir, V naught by root 2. I would have marked it, no, sir. Guys, it was just by coincidence that it came out to be V naught by root 2. I'll tell you, if the graph went down like this, then I don't think it will come as V naught by root 2. Or if the graph was something else, then it will not be V naught by root 2. Shravana Kumar, aren't you happy? At least I'm wearing shorts. Be happy, man. Chill, no. Okay. I'm done with chemistry, physics pretty good. My maths is weak. Practice. Well, any suggestions for me? Math, you can't do anything, bacha. In the last few days, it's very difficult because maths is like an art. You have to practice it day in, day out. But yes, there are certain chapters which you can improve. Pick up the easy ones, high weightage ones, and practice them regularly every day in the morning. Ishan, I don't want to know. Thank you very much. Can I just unsee that chat for some reason? Okay. The inductance between A and D is 1, 2, 3, 3H, 3H, 3H. What is the net inductance? Sir, I'm confusing, sir. My friends are said HC only for mains and Cengage for advance. Hi, chill, man. I'll tell you, when I used to prepare, no, my friends also used to buy hundreds of books like this. I also cleared, no. I got better rank than them. Many of them didn't clear, buying those God knows what and all they bought. So don't worry, have faith. For advance, you need advanced material like obviously Irodov, H.C. Verma, exercise problem solved examples, PYQs. D. Mukherjee is one other good book. Or if you have already enrolled in Vedantu, you get the Tattva material which has level 3 and level 4 problems, solve that. Okay, come on, let's do this. Inductance. This circuit is very much similar to a resistive circuit which you would have solved back in current electricity, like this, like this, like this. And you remember that these three resistors were actually in parallel. Same logic is also used here. If this has a potential A, this also has a potential A. If this has a potential D, this wire will make this point also have potential D. Take any inductor, each inductor has same dot circle, all are in parallel. So basically it's three inductors in parallel, 3H, 3H, 3H. That's it. One is a dot, other is a circle. Dot, circle, dot, circle, dot, circle. They are parallel. Now the only problem is when in the case of inductors, do you add them or do you take reciprocals and add them? Think about it. Think about it. Well, the formula is exactly similar like resistors. So resistors and inductors are alike, and exactly opposite is basically capacitors. So for capacitors, when in series, use the parallel formula of resistors and vice versa. Here they are in parallel, so just use L1 by LP is 1 by L1 plus 1 by L2 plus 1 by L3. So it is basically 3 times, because L is same, 3 times 1 by 3. So it will be just 1. So LP will also be 1 Henry. Done. 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 Very similar to resistance. Perfecto. Here we go to the next question. A series resonant circuit LCR. The voltage across R is 100. Resistance is this much. Capacitance is this much. Resonant frequency is this much. At resonance, the voltage across L is how much? Wow, this is good question. Let's try to do this. Series LCR circuit. Okay, that's one keyword. It is also resonating. Okay, keyword. At resonance, voltage across L is. Let's think about vectors. So this is VL. This will be VC. This will be VR. We know VL and VC is equal at resonance. So that's one thing. VL is equal to VC. Fair enough. Do I know L? No, I don't know L. Inductance I don't know. Capacitance I know. Achha. And I also know one more thing. VC is current into XC, and XC is 1 by omega C. Omega I know. C I know. Current I don't know. Okay. But I know resistance. I know the voltage across the resistance. And I know in series current is same. Be it this or this guy, all the things have same current. So voltage across the resistor is current into the resistance. Voltage is 100. Current I do not know. Resistance is 1 kilo, that is 10 to the power 3. So the current is 1 by 10 amperes, which is same for L, C or R. Doesn't matter. It's the same for L, C or R. Now substitute it. The current value is 1 by 10. Omega value is 200. C value is 2 micro. So 2 into 10 to the power minus 6. This is VC, but VC is also, from this concept, also equal to VL. So hence VL will be equal to 2 2s are 4, so 1 by 4 into 1, 2, 3, 3 zeros and 10 to the power minus 6. So 10 to the power minus 3 goes on the top, it will become 10 to the power 3. So that's 1000 divided by 4. Should it be 250 volts? Check this out. 250 volts. Yeah, it is. 3 zeros and 10 to the power minus 6 will make it 10 to the power minus 3. Goes on the top, becomes 10 to the power 3. 1000 divided by 4 is 250. Alright? Makes sense. Yeah. Fair enough. Moving on to the next one. Made a mistake, I guess. No problem. Okay. So will I be able to clear mains with good marks if I'm done with concept but not with sums problems? No, Deepthi. If you are done with concept, no point, Deepthi. Problems are the thing which will make you clear. A metallic conductor of length 1 meter rotates vertically about one of its ends with angular velocity this much. If the horizontal component is this much, then EMF developed across the ends is. So there is a rod and it is hinged here. It is rotating like this in the vertical plane. Horizontal component of the Earth's field is also given. Guys, come on. This is simple. EMF, I just told you, it is half B omega L square. B is known. This 0.2 into 10 to the power minus 4 omega 5 L 1, so 1 square. Oh, it's going to go. So this will be nothing but 0.1 into 10 to the power minus 4 into 5. So this will be 5 into 10 to the power minus 5. So you can write it as 50 into 10 to the power minus 6 volts, which is 50 microvolts, which is 50. Option B. Hey, there you go. Done. Standard, no problem. I give you this formula also I discussed with you. That's it. I think we have come to an end. Yes. So guys, if you want more questions and if you want to practice more tests and if you want my classes along with class notes and more problems which are very different from the YouTube problems, okay, I will never use the same problems in the same thing. Those classes are there for your JEE as well as NEET. For NEET you have PCB, for obviously JEE you have PCM. All the assignments for all the subjects, all the chapters which are going to keep you busy for obviously next 2 months. Okay, make the best use of it, because you know this is the last ditch effort which you can do, and you might have got saturated and you need a new approach, you need a new thinking, you need a fresh mind. So probably you can build up a fresh mind. Watch my classes on YouTube plus the crash course classes. That's the best combo, the deadly combo, which will help you gain marks. A lot of students who are in 4-digit or 5-digit ranks, or you know expecting that much, have got to 3-digit, 2-digit ranks as well, you know, from a very low score. So things have changed because of the students' confidence, because of their faith, and because of their hard work and patience. All credit goes to the student, and I'm so glad that they took the help of the crash course for, you know, achieving their dreams. And now they are doing really well. You too can do that. The price is just $2,700. Link is there in the description box. Go ahead, check it out. I'll just show that to you. Right over here, where, let me just go. So when you go down, all right, first of all you will see that JEE crash course, NEET crash course. It's in pure English, by the way. So if you open it up, it will show physics, chemistry, maths. How will this course help you? The testimonials, results produced from the batches, and the teacher details, the study material, everything. This is 5-week course. There's no time to waste. Don't wait for the board exams to get over or anything. Click on this, you save money, multiple options right over here. Okay, coupon code should be applied, or else you will miss out on the offers. And same thing for NEET as well. You can see again, this is 5 weeks, 120 classes. Again, 2,700 rupees. Again, you will save money. You have again multiple options. For today's class, I have already put up the week quiz link. This link will help you solve questions. These are like homework questions. Make sure you click on this link and start attempting those questions which are there in the week quiz. Okay, that's something which I want you to do. Okay guys, fine. So let's have a look. Yep, how much can I see? Guys, I cannot commit on anything. Like, I cannot tell you with this series how much you can score, with that series how much you can score. I can tell you your marks will improve 100%. Your score will improve. See, stop watching those videos where you are told that you watch this series, you will get this much marks. No, even when I tell you that I will tell you the strategy for getting you these marks, I will tell you what and all you should do. It's never by watching, it's always by practice. By watching, you will never score. It's always by watching and practice and learning through mistakes and practice and testing yourself. That's how you score. Keep this in mind. Okay? Because when I'm doing daily basis, I'm missing present. So through mind maps is a better way of revision. Hi-fi. Okay? Thank you guys very much. Have a great time. I hope you enjoyed the session. You enjoyed the problems as well. Stay safe, stay well. And I'll see you guys tomorrow in the motivational session and also the casual talk session. Bye bye. Take care. Hasta la vista.